we want to evaluate the line integral along the curve C, where the curve C is a line segment from the point 0, 6, 2 to the point -1, 8, 7. So our first step is to parameterize the curve C, or this line segment, which means we need to write parametric equations for this line segment. And if we can just look at these coordinates and write the parametric equations, that's great. But if we struggle with this, we can always use these equations here for the parametric equations for a line segment in space, where x sub 1, y sub 1, and z sub 1 would be the coordinates of the first point, and x sub 2, y sub 2, z sub 2 would be the coordinates of the second point. So here we have x sub 1, y sub 1, z sub 1, and x sub 2, y sub 2, and z sub 2. When we define a line segment using these equations, the interval for t will always be the closed interval from 0 to 1. So for x, or x of t, we would have the quantity 1 minus t times x sub 1, which is 0, plus t times x sub 2, which is -1. Simplifying, we just get x of t equals -t. For y of t, we would have the quantity 1 minus t times y sub 1, which is 6, plus t times y sub 2, which is 8. So simplifying, we get y of t equals, we'll have 6, and then -6t plus 8t, that's plus 2t. And finally, for z of t, would have the quantity 1 minus t times z sub 1, which is 2, plus t times z sub 2, which is 7. So we have z of t equals 2, and then -2t plus 7t, that's plus 5t. So the parameterization of the curve C is x, or x of t, equals -t. Y of t, or y, is equal to 6 plus 2t. Z, or z of t, is equal to 2 plus 5t. And again, t is on the closed interval from 0 to 1. Now that we've parameterized the curve C, looking at our notes below, to evaluate the line integral, we're going to write the integrand function as a function of t using the parametric equations, and then differential s is equal to the square root of x prime of t squared plus y prime of t squared plus z prime of t squared dt. Let's go ahead and find x prime of t, y prime of t, and z prime of t. So x prime of t is going to be equal to the derivative of -t with respect to t is -1. Y prime of t is the derivative of 6 plus 2t, which would be 2. And z prime of t is equal to the derivative of 2 plus 5t, which would be 5. Now for our next step, let's go ahead and write the given integrand function as a function of t. Well, we're given f of x comma y comma z equals x squared plus z, which means f of x of t comma y of t comma z of t would be equal to, again, x squared would be -t squared times z, which would be times the quantity 2 plus 5t. Now let's find the square root of x prime of t squared plus y prime of t squared plus z prime of t squared. So we'd have the square root, x prime of t squared would be -1 squared, plus y prime of t squared would be 2 squared, plus z prime of t squared would be 5 squared. So here we have the square root of 1 plus 4 plus 25, which is the square root of 30. And now we have all the information we need. So the line integral along the curve C of x squared z integrated with respect to s, or arc length, is equal to the integral of f expressed as a function of t, which we already found here. Let's go ahead and distribute. We'd have t squared times 2, that's 2t squared, and then plus t squared times 5t, that's plus 5t to the third. So we have the quantity 2t squared plus 5t to the third. And we already found the value of the square root to be the square root of 30, so we have times the square root of 30 dt. And now the limits of integration for t are from 0 to 1 because we set these parametric equations up so that it traces out this line segment from t equals 0 to t equals 1. Now let's evaluate this on the next slide. Let's rewrite this as the square root of 30 times integral from 0 to 1 of 2t squared plus 5t to the third. Integrating with respect to t, we're going to have the square root of 30 times the antiderivative of 2t to the second with respect to t is going to be 2 times t to the third divided by 3, or 2/3 t to the third, plus the antiderivative of 5t to the third is going to be 5 times t to the fourth divided by 4, or 5/4 t to the fourth. So evaluating here, we're going to have the square root of 30 times, when t is equal to 1, we'll just have 2/3 times 1 to the third plus 5/4 times 1 to the fourth minus, when t is 0, notice both terms contain a factor of t, so both terms are going to be 0. So we have the square root of 30 times the quantity 2/3 plus 5/4. Obtaining a common denominator, which would be 12, we'll multiply by 4 over 4 here and 3 over 3 here. So we have the square root of 30 times, here we're going to have 8/12 plus 15/12, which is 23/12. Let's go ahead and write this as 23 square root of 30 divided by 12, which as a decimal would be approximately 10.4980. I hope you found this helpful.